So, I've installed solar panels. I've even got a home battery. I've bought an electric vehicle. So what's next? How about a heat pump? Since I started my electrification journey, I've considered getting a heat pump installed, as this would be the last piece of the puzzle to get me off gas for good. Saving money on the gas standing charge, reducing my energy bills even further, and also helping the environment too. But I've never been quite able to convince myself that this is actually worthwhile. My boiler is around 6 years old and works absolutely fine. We don't use too much gas anyway, and our house is relatively efficient. So those factors combined with the hassle of an installation, even combined with the boiler upgrade scheme grant, which currently stands at £7,500 from the government, I could never quite justify it. However, I recently appeared on Heatio's Home Energy Show podcast. You can check that out here or view it in the video description. And on that podcast you'll learn how my YouTube journey started, some energy saving tips and much more. And collaborating with them has given me the opportunity to get a heat pump installed for myself. But the world of heat pumps can be quite confusing. What is a heat pump? How does it work? What things do you need to consider? And who are Heatio anyway? In today's episode I've teamed up with James and Gareth from Heatio, and I had a quick chat with them to ask some of these questions and also questions specific to my install as well. Stay tuned to find out more. Hi everyone, I'm Danny V Solar. Welcome to my channel. Here you can follow my journey all things electrification. Please hit the like button if you find this video useful, and also subscribe to my channel to follow the installation of my heat pump through to the end. In today's video I caught up with James and Gareth from Heatio, and they answer some of the pertinent questions relating to heat pumps. Hopefully this helps some of you out there as well that are looking to get heat pumps installed for yourself. Let's get into it. So I'm here today with James and Gareth from Heatio. Can you two just start by doing a brief introduction to both Heatio and your roles and what you do within Heatio?
Yeah, so my name is James. I'm the sales manager here at Heatio. I previously worked in New Zealand for a solar business that provides an energy service. So it looks to provide demand response to the national market over there in New Zealand. And then I heard we're looking to do something similar at Heatio, and so I moved over.
So my name is Gareth. I am the installation manager. So once James has done sort of the front end, speaking to customers and engaging with them about their decarbonisation journey, I will then take over and manage the installation, whether it be a heat pump, solar, battery. That's my job to deliver what the customer needs.
Okay, so can we just explain a little bit about who Heatio are and what you do?
Yeah, so Heatio, we offer two core solutions. So the first one is for homeowners to install smart technology in their properties. And we use that by using a data-driven approach. So in that, we analyze their historical energy patterns, and that allows us to also understand their motivations and their energy savings goals. So once we understand their usage, what their motivations are, and what they'd like to save, we use that data to demonstrate potential cost savings and also provide a tailored solution for that renewable installation. The second core value at Heatio is to focus on homeowners that already have the technology installed. So our system is called Heatio Energy. It's our online platform. It connects technologies in the home using a combination of AI and smart algorithms. And that allows us to understand how the homeowner uses energy and then optimize that energy. So we bring all the energy, the smart technology of the property to work together in harmony. This solution also works with smart tariffs. So we take advantage of the lower energy prices at certain times of the day. And then of course we try to level out those periods where it's at the peak rates. So this platform is already live and you can use it at heatio.com.
Okay, so I'm just at the very start of looking to get a heat pump. I'm sure there's a lot of people in the country at the moment with the whole decarbonisation route in the same position, looking to get a heat pump but don't really understand a lot about what the installation process involves and that kind of thing. So can we just, I guess, start with the basics and discuss what a heat pump actually is and how does it work?
Yeah, of course. So a heat pump is essentially the same as a gas or an oil boiler. It provides heat for your space heating and heat for your hot water. without getting sort of really into the nuts and bolts of it, an air source heat pump has an outdoor unit which absorbs heat via refrigerant. The fluid is then turned into a gas and passed through a compressor cycle which increases the pressure and the temperature. This increase in temperature is then transferred into the water that can be circulated around your home and provide heat and hot water. So instead of having a gas boiler on the wall of your kitchen or your utility room, you would have a box outside, essentially.
Okay, and that's just taking the cold air in, compressing it, and sending that around the radiators in liquid form, I guess, throughout the house.
Essentially, yeah.
Yep. So in terms of benefits of using heat pumps, what's the differences compared to using a standard boiler or an oil heater, that kind of thing?
Yeah, so with heat pumps, they're more energy efficient than traditional boilers because they transfer heat rather than generating it through combustion. And they use electricity to move that air from either the air or the ground. They also produce lower carbon emissions, so they can contribute to a reduced environmental impact, and that also has a longer lifespan than traditional boilers. It can improve your EPC rating, so if you're thinking of selling, that can be an additional add.
Mm-hmm.
And of course, some people don't know, but the government's put a target to reduce 80% of gas boilers by 2035. So I guess it's becoming less of a question of if, but more of a question of when.
Mm-hmm. Yeah, and it feels like there's been a lot of bad press around heat pumps in general. Is any of that founded? Is the articles we see, are there any drawbacks or limitations with heat pumps that you get from a gas boiler, or are they quite comparable?
I think that with the government incentives, they're trying to disprove a lot of those rumours. There are only two things that kind of spring to mind, and that would be, of course, the complexity of installing a heat pump. That would require maybe the radiator upgrades or the piping. And heat pumps, traditionally the air source heat pumps require a bit more space outside.
Mm-hmm. Yeah.
But those are the only two key kind of thought processes that go into installing a heat pump over a boiler.
So what makes for a good or bad install, and when a company like Heatio installs a heat pump, what are they doing to ensure that the heat pump works as effectively as possible?
That's a really good question. I think air source heat pumps get their efficiency from blowing at a lower temperature than what a gas or an oil boiler would do. So to make sure the installation is good or successful, we would have to ensure the design is correct and done properly. So that would include sizing the unit and the emitters. So emitters could be underfloor or radiators. We would have to look at the location of the air source heat pump, make sure that the flow and return pipes are correctly insulated, so that we're not losing heat because we are running at those lower temperatures. And we would have to spend time setting up the controls, setting up the weather compensation, and making sure that you as a homeowner understand how to use the controls or how not to use the controls, and depending on the situation. Mm-hmm. And then of course you've got actually executing and physically installing the pipes, the heat pump, the way it needs to be done. So all of that would come together to make sure we have lower running costs, or the running costs are to be around what we've forecasted in our performance estimate. Mm-hmm. I think obviously from a customer point of view, a successful installation is something that doesn't have high running costs, and that you feel warm and that you have hot water in your property. I think the flip side of that is probably getting one or a couple of the elements there that I've mentioned wrong, or not doing it correctly, resulting in higher running costs, a homeowner not feeling comfortable or warm enough in their property. So I think that's sort of the difference between a good or successful install and potentially something that is bad or poorly installed.
Okay. Yeah. So you mentioned a bit about the end user needing to have some education when they get installed. Is this something they need to be monitoring ongoing, or is it just a case of set it up once, make sure they know how to change things, and then off they go?
I think there's a lot on the market there of developments that have or will provide monitoring. So, there's apps out there that you can connect to, whether it's a gas boiler or an air source heat pump, to monitor the performance. Ideally, the installer and the homeowner will have conversations about how they use it, how they want to set their hot water and their heating times to come on. With a heat pump, we would generally recommend using weather compensation as the control mechanism. So it's not a case that you switch your air source heat pump on and you switch it off. The idea is that the systems that we have and gas boilers do have, but it's really important for the heat pump that the weather compensate runs and is the brains of it. There are elements online now that you can get AI integration and optimization to make sure that the system is performing as well as it can do.
Just thinking about my install in particular, so I guess just to give a bit of background on where we're at, I've worked with you guys for a little bit now, and Jake did the heat loss survey on my house the other day. So can we just talk a little bit about the equipment that you be installing for my install, brands of heat pumps, what you're using, thinking for hot water, that kind of thing?
Yeah, of course. So we're looking to install a Samsung R290 air source heat pump. This is a single fan unit which will sit outside, facing your back garden. It's the first Samsung to incorporate a low range refrigerant. So that's the R290. Samsung have a really good track record in the UK, and it is provided with a 7-year warranty as well. The unit itself is simple to install, affordable, and it does maintain excellent capacity at the lower temperatures. Coupled with that, we are going to install an energy pod. So that will sit inside the carriage. It can sit externally, but you've got space where your existing PV system is and underneath the boiler. So within the energy pod, there will be a 300 sun amp unit and an X Plus that will provide your domestic hot water. And on the other side of the energy pod, there will be the battery, the additional GivEnergy battery. And there is also space in there to fit the current inverter and battery that's at your property. So essentially, you will roll the unit off the van, throw it into the garage, and then connect in the cables and the heating and hot water, and you'll be all ready to go.
So just talking about the energy pod then, what's the benefit of having the energy pod versus the normal air source heat pump and sun amp installed separately?
So the energy pod, it offers solution not only for, say, you as the homeowner, but also for the installers as well. So one of the common issues you usually find when you transition from, say, a combi boiler and install a hot water cylinder is the space constraints. So when you install the sun amp in the energy pod itself, which can be mounted internally or externally, you actually get to reclaim a bit of the space in your property. So if you can imagine from the installer side, if all of the equipment is consolidated in one place, they can roll it to site, install it, and things like maintenance and upkeep become very straightforward. So for both the homeowner and of course the installer, it's extremely valuable.
And does it need any special permits or permissions above a normal install?
No, nothing from a traditional install of this equipment. It's exactly the same.
And just, I guess, from my limited understanding, you can either have, for the hot water, you can have a hot water tank or something like the sun amp. What's the differences in those two?
So the key difference is sun amps and traditional water tanks are relatively the same in regards to the technology, but they differ in some instances, such as sun amp units are more compact. They use the phase change material, and so that's to help for thermal efficiency and minimal heat loss. They also provide hot water on demand. So when you need hot water instantaneously, it goes through the sun amp and it's provided into the property. Unlike when you look at traditional hot water tanks, the water needs a bit of time to heat up. Mm-hmm. You'll also find that traditional water tanks, they're of course a little bit cheaper, they're more well established, and they've got more capacity or more varying capacity. But they do come with the drawbacks with heat loss, longer reheating times, and they do require a bit more space. So we do install both options, of course, but SunAmp has become the more modern and efficient choice for Heatio.
Okay. So I'm kind of thinking of this like SunAmp is the equivalent of a combi boiler where you get that instant hot water, and a water tank is the same as a water tank with a combined with a boiler, I guess.
That's a great way to look at it, yeah.
And just in terms of, you mentioned the outside box needs to go somewhere. What are the factors in determining the best location for that?
Yeah, so I think you could probably split them into two categories really. So you've got, the practical requirements. So we would have to look at the manufacturer's guidance to make sure that we are meeting all the service requirements with regards to clearances at the back and at the side of the unit. We then have to factor in the pipe runs. So where your flow and return pipe needs to run to and from. Same with your cable routes. Obviously, we need to get from your consumer unit out into power the heat pump, and then from the heat pump back into the control board. We also have to take into consideration, how you as a customer or the end user actually use the outdoor space.
Yeah.
If you've got a seating area somewhere, do you want the heat pump to be blowing cold or cooler air into that seating area?
Mm-hmm.
You probably don't, so we would have to look at a suitable alternative. The second element would be the statutory requirements that we would have to adhere to. So in England, the permitted development for the heat pump means that the unit has to be more than 1 metre away from the boundary. In Wales, that is 3 metres. So that can slightly reduce, the location, the availability of the location. I know there are some consultations, and industry are asking if those can be reduced to facilitate more heat pumps going in. We also have to consider the MCS noise calculation, so MCS 202 for permitted development with regards to the noise that your neighbours would hear off a heat pump.
Yeah, so just on the noise piece then, from what I've done from our research, it seems like the modern heat pumps don't really have this issue. There might be a low hum. Is that the case, and is that why they're trying to remove the limitations for the boundaries?
Yeah, you're right. Obviously, as technology develops, sort of legislation sort of can lag behind somewhat. And modern heat pumps aren't particularly noisy, and unfortunately, we have our hands tied as an industry that all heat pump installations that go through permitted developments have to adhere to this noise calculation. So until that changes, that's something we have to abide by.
Mm-hmm. And then just in terms of the calculations, I'd mapped out on HeatGeek a while ago, just for my learning really, mapped out our house. I'm curious to see how close your calculations were to what I got. But the calculations are, I guess, there's some quite complex calculations that go into determining the heat loss in the property. How do you go about that, and how do you determine from those calculations what the appropriate size of heat pump is?
Yeah, so there's a British standard, so BS EN 12831, that specifies what to do and how to do it, and the calculations need to adhere to that. Fortunately, there are calculation software tools that are available to us as installers and to homeowners to go online and find them out. So the heat loss calculation is a process for estimating the heating requirements of a building. They will give us an indicative heat load for the entire property as well as for individual rooms, and then that will also determine the size of your emitters or the requirements of your emitters for each room. There are a lot of conversations happening within the industry with regards to how to digitalize this and how to make it as accurate as possible. We here at Heatio have a system that can calculate the heat transfer coefficient of a property, and that involves a little black box and some temperature sensors that we place in certain rooms that will actually accurately measure that specific property. Sort of what Jake did he undertook a room-by-room heat loss survey. So he is measuring the area, the height of the rooms, the area of the windows, the type of windows, same with the external doors, looking at the emitters as well, so again the size and type of emitters. All of that is put into, say, the calculation software. We then have to consider ventilation and air change rates that are taken from the CIBSE guide. You wrap all that together, and that will give you the peak heat demand of that property. So from that we can then size a unit to make sure at the outdoor design temperature that unit is capable of meeting 100% of the heating demand for that property. Off the back of that, we then also have to look at what flow temperature we would like to flow at. Obviously, air source heat pumps get the efficiency from flowing as low as possible, and that then impacts the size of the radiators that may be required in those rooms. So it's a fairly lengthy process. Like I say, the industry is making some really good improvements and developments on that process and trying to become as accurate as possible. But there is, I think, probably a long way to go on that as well.
So in terms of the installation process itself, what can I expect from that? How long will it take? Is the house going to be upside down for 2 weeks, or what's involved in that?
Yeah, I think there's, with any sort of alteration to your house, there's always going to be that disturbance, if you like. We would look to do your install probably in 3 to 4 days.
Yeah.
So that would include, prep and siting the external unit. I think we're looking at potentially the option of using insulated underground pipe. So there's some pre-enabling works that are required for that around the trenching. Like I mentioned before, we would then have to run cables from your consumer unit to your external unit and then back into your house. We have got to site and fit your sun on, which is going to go into the garage in your case.
Yep.
Again, we need the specialised lifting equipment, upgrading the radiators that we've identified from the heat loss, amending or changing any pipe work that required. We would then go into sort of the changeover, if you like. So then we would look at decommission your gas boiler, change it over to the air source and the heat pump, get the commissioning and the control set up. So, all that happens in stages. I think sometimes until you start, actually getting on site and lifting floorboards up and finding, the pipe runs, you can run into various issues that you may not be aware of.
Yeah.
Because our surveys are sort of non-intrusive. And with all that comes, general construction. So there'll be people coming in and out of the house, there's drilling noises, things like that. Obviously, we do our best, and we pride ourselves on, leaving the property as we found it. So we would make sure that everything's clean and tidy before we finish. Make sure you're happy with the installation. You understand the controls and how we've set up the heat pump for you and your property and your requirements.
And just on the piping piece, so my house is coming up 6 years old now, and it's got 10mm microbore pipe throughout. You hear kind of conflicting reports on whether this is suitable for a heat pump. Can you just give your opinion on that?
Yeah, I think you can probably go and ask 10 engineers and get 10 different answers on that, I would imagine. From a sort of design point of view, you just have to make sure, that the emitter and the flow rates are correct to overcome any resistance or reduced flow rates that those pipes may cause.
Yeah.
We would look to make sure that the system is correctly balanced, spend a bit of time doing that, making sure that there are no cold spots. Our engineers have worked on properties that have got 10mm pipe, that have got properties that we've worked on have got 8mm pipe, and their systems work, no problems. It's just all about that design and that setup.
Okay, so just on the zoning piece then, so my house currently has 2 different zones, upstairs and downstairs. How does that work with a heat pump? Does that need removing? Can you just comment on that for me, please?
Obviously, having a zone provides its benefits, allowing you to control the different zones with different temperatures and how you occupy and use those zones and those rooms within them. So that's a really good benefit. From a Heatio perspective, we would take the approach that we would need to essentially open loop your system, so that is connecting those two zones together. That will simplify the flow around your property and potentially improve, response and heat up times. From, as I say, from our point of view, zoning is good and has its benefits in certain applications. If you're looking to make that switch to a heat pump, we would recommend that the system is one loop, or that is open loop.
I guess the benefit of that is you get a constant temperature across the whole house, upstairs and downstairs, all the time, rather than just heating above or below. So you hear a lot about the costs of heat pumps and how expensive they are compared to a traditional boiler install. Is that still the case? Are the costs coming down? Obviously there's the bus grant, so the boiler upgrade scheme available from the government as well. Where are we at with that at the moment?
Yeah, so you're correct. So the kind of the purchasing and the installation costs associated with heat pumps does depend on several factors. So as Gareth mentioned, we conducted a detailed site visit. We look at the size of the system and do a bigger overview of the property. But as you mentioned, the government provides that £7,500 grant. So that's built to encourage homeowners to switch to that low carbon energy system before that large scale ban on fossil fuel energy, as I mentioned before. But what you'll find is, say, a boiler might be, give or take, £2,500. Most of the installations we do is about £5,000 for the supply and installation. So you're starting to get into a position where over the course of, say, a 20-year lifespan, 15 to 20-year lifespan with an air source heat pump, it's starting to become more economical.
Yeah, just in terms of lifespan, are we saying that heat pumps last longer than boilers usually, or is that dependent on the manufacturers?
So with maintenance on an annual basis, you'll see that a heat pump can have a lifespan of 15 to 20 years, sometimes even longer.
Mm-hmm. So in terms of running costs, then what is is there ways to save money with a heat pump? What can you do with other renewable sources and that kind of thing?
Well, by installing a heat pump, you've already made a smart decision to start to save money. But if you pair a heat pump with solar panels and a battery, that can further expedite the return on investment, which I'm sure you'll see with the solar system at your property. Mm-hmm. So by generating your own solar, you can offset your daily usage, and any additional surplus energy can then be fed into the battery. So you can imagine that stored energy can then be discharged to heat the heat pump during, say, peak hours when you return home from work or when you're cooking. I guess in addition to that, what you'll find is you can use off-peak energy tariffs and an energy management platform like Heatio develops. So you can buy energy on the overnight off-peak tariff, store that energy in the battery, and then discharge that energy in the early morning. So to reduce that other peak time period that comes into play.
And just a few wrap-up questions, I guess. So in terms of installers, we mentioned a good installer is key to get that kind of return on, get your house heated properly and also save money on your gas, what would be your gas bills, I guess. What should people be looking for with qualified installers?
Yeah, so I think the first point to get access to the bus grant that we mentioned, the installer would need to be MCS certified. So that means that they have got an accreditation, they've met industry standards that are set out there with regards to the customer journey, right from conception all the way through to sales and installation. Personally, I would always, look at their reviews and ask for some case studies if they're available, and even push to see if you can speak to previous customers, because they're the people who've gone through that full journey with that installer, and they're the people who have got actual hands-on experience on what things they may do different or things that you should look out for. But essentially, if you want to get access to that bus grant, the installer should be MCS certified.
So I've had my heat loss survey. You guys are working on the heat loss calculations at the moment. What's next in the process for me?
Yeah, so your next step will be that we will complete your design proposal. We will send it over. You've identify the unit, the location, we've said, we've discussed about the sun amps. You will get all the performance data, performance estimates that come along with that. We will discuss the radiators and the potential for upgrades, and the timeline for that, i.e. do you want to just leave them for now and see how the installation goes, or do you want to upgrade them with the system? We would then ask you to pay a 25% deposit. Obviously, as we know, you have got a solar and battery, and for some other reasons with regards to the Samsung unit being connected notified, we have to go through a DNO application. Okay. And then once we've got approval there, we can then book you in for an install and come and do the job.
Sounds good. So we haven't really touched on efficiency too much, but from my understanding, with a boiler you're getting probably a maximum of 90% efficiency. What's possible with heat pumps?
Yeah, so as you mentioned, gas boilers, they typically have an efficiency of around 80 to 90%. So they convert nearly all of their fuel into heat. But when you're talking about a heat pump, it can get anywhere between 300 to 400% efficiency. So if you think about it in units, 3 to 4 units of heat for 1 unit of electricity consumed. So they're highly efficient. Mm-hmm. That paired with the lifespan provides a longer savings over time.
Sounds like magic when you say you put 1 kilowatt of energy in to get 3-4 kilowatts output. Right, I think that was all the questions I had, so I appreciate your time. Thanks, Gareth. Thanks, James, for taking the time to speak to me.
No worries. Cheers, Dan.
Thank you, Dan.